Hello all, welcome to the live session of Langchain at day 6. Right. So let us quickly recap what we have done till now, and then we will start today's agenda. Right. So in session 1 and session 2, we have discussed how to interact with a large language models. Right. So be it a proprietary model or be it a open source model. So both the models in the case of proprietary models, we have seen how to create API keys, and then we have interacted with proprietary models. In the case of open source models, what we have done, we have downloaded a Hugging Face model locally, and then uh, we have successfully interacted with the model, open source model as well. So that was our session one's agenda, and we have seen enough practicals how to interact with different kinds of proprietary models. I have shown you how to interact with OpenAI models, how to interact with Gemini models, and also I showed you how to interact with uh, a tiny llama model by downloading from Hugging Face as well. Correct. In the session 2, we have discussed about how to make templates, prompt templates, right? We have seen how to make a prompt template. We have seen how to make a static prompt template, a dynamic prompt template. We have also discussed what is a chart prompt template, and also we have seen n number of examples on how to constructing these prompts as well, right? So that was the session one and session two we have discussed, and then uh, in session 3 and 4, we completely discussed about a RAG system, right? So we have discussed about document loaders, we have discussed about text splitters, we have discussed about uh, vector stores. So practically we have seen how to use ChromaDB, how to use Facebook AI similarity search, and also we have seen a cloud-based vector store, which is Pinecone. How to use a Pinecone vector store as well. Uh, we have seen in examples, right? So after that, in session 4, we have built a basic RAG-based application, and we have successfully uh, tested our RAG application as well in the session. Now coming to this week, uh, this yesterday we have discussed about what is memory and what kind of memories are available in Langchain. We uh, we have seen with you know how to implement the memory and what problem we are going to solve when you are building any workflows or agents using a memory component, right? So after that, we have discussed about multimodality, right? What is multimodality? And also we have interacted with LLM by sending image as a input data, correct? All right. So after that, we have discussed about chains and runnables, and practically we have also implemented a runnable sequence. Right. So today's agenda is whatever the remaining topics yesterday. We are going to continue that, and we are going to finish those topics. So we are going to start with a runnable parallel. What is runnable parallel? And a runnable pass through, what is runnable lambda, what is a runnable branch, and also we will see four different kinds of examples where we are going to use these runnables, correct? After that, we will move to a tools topic, so which are important component in Langchain ecosystem. So we will define couple of tools. We will see how to do a tool calling manual, right? Generally, tool calling will happen automatically by the Langchain framework. But for better understanding, what we will do, we will define our own tools, custom tools, and then we will see how to call these tools manually instead of uh, framework is initiating call, so that you will get the better understanding what will happen when LLM is initiating the tool call, correct? So this is going to be our agenda today. Hopefully we can finish these things. Once we finish this, then next week we are going to enter into agents concept, and also we will see one capstone project as well, right? So with this, let us discuss about runnable parallel. So yesterday we have discussed enough about what is runnables. Basically, uh, every component in Langchain ecosystem is a runnable. So this runnable interface gives us, you know, uh, a common methods like invoke, batch, stream. All these common methods will be used. And runnables are two types of runnables exist in Langchain. So one is a task specific, you know, task specific runnable, and one more is sorry. uh, One is task specific runnable and one more is a primitive runnable. So in task specific runnable, we have seen enough of examples. Every component we used till now in Langchain, be it prompt, be it LLM interaction, right? Be it output process or document loaders, everything is, you know, a task specific runnable. Now, yesterday we successfully introduced what are primitive runnables, and also we have seen an example of what is a runnable sequence, in what kind of situation we need to use a runnable sequence as well. Right. So today we are going to discuss about a runnable parallel. So before going to let us see the definition of what is a runnable parallel. Right. So runnable parallel, as name suggests, it allows parallel chains execution. Parallel chains execution, it means if two tasks are there and both the tasks are independent on each other, right? So task 1 is not dependent on task 2, and as well as task 2 is not dependent on a task 1. So basically both the tasks are independent tasks. So just think this way: if both are independent, if you use runnable sequence, generally what will happen? One component will execute, and that component's output will go to second component as an input, and then second component will process it and produce the output. That output will go to a third component, and so on, right? So if both the tasks are independent, in case of runnable sequence, all are dependent. See, your second component is dependent on your first component, and your third component is dependent on your second component, right? So because of in that cases we need to use a runnable sequence. But let's say you have a couple of tasks to do and both are independent in nature. In that case, what you have to do, you have to use a runnable parallel, right? uh, I hope you got the point. So let's take a simple example, and I will simplify further more what is when to use runnable parallel. uh, let's say till now we have discussed about Langchain, right? Now I want to give some assignment which is a uh, multiple questions assignment. I want to give it to my students, right? So I want to generate five multiple questions in each category. Let's say I have divided three categories for my assignment. First category is a beginner category, second category is intermediate category, and third category is advanced or expert category, right? Now I want to give a five multiple questions in each category. So technically if you talk, I need a 15 questions, five questions from each category, right? uh, then if you observe carefully, my topic is same. What is my topic? My topic is Langchain, but my category is different, and uh, each category is independent. So instead of i'm uh, instead of using runnable sequence, normally what will happen, I will pass my prompt with category easy, and then I'll call LLM and I'll get output. Then I'll pass second prompt and I'll call LLM, and then I'll get you know intermediate questions. In and third step, what I have to do, uh, I have to pass third prompt to the LLM, and LLM will generate five multiple choice questions to me with the level hard or difficult level, right? So if you execute these tasks sequentially, then there will be, you are wasting a lot of time, correct? So three LLM calls, you basically all are independent tasks, and you are, wasting your time on for executing these tasks sequentially. So instead, what you can do, you can use runnable parallel. You can use runnable parallel. All these three tasks can run independently. Can run independently at same time. Can run independently at same time. Let's say one LLM call for general. Let's say one LLM call is taking 1 second, and to finish these three tasks in sequential manner, what you have to do, you have to wait for 3 seconds to get the complete output, right? So but if you use runnable parallel, since all tasks are executing parallelly, so all three can be finished within a second, correct? So what advantage we are getting over here? We are getting the advantage of, we are reducing execution time using runnable parallel. And remember, runnable parallel you have to use when there is no dependency between the tasks. If there is a dependency, obviously you need to use the runnable sequence, right? I hope you got my point. If you got it, let us go to our flow chart and see what we are going to build practically using runnable parallel, correct? All right. So we have discussed enough about runnable sequence chain yesterday. So let's do one thing. Today we are going to discuss a runnable parallel. Correct. Now let's say uh, I have one topic. I have one topic, and I want to generate on that particular topic a LinkedIn post or social media post, right? Whatever the content is required for LinkedIn post or social media post, I need to generate some content on that particular topic. Let's say my topic is a Langchain, so I need three things. I need three things from my uh, workflow. First, first task what I'm going to do is I'm going to generate a content for my social media post or my LinkedIn post, right? So that is my task one. That is my task one. And second task, I am also having a blog. I am also running a blog, right? I need blog content as well, right? So that is going to be my second task. That is going to be my second task. Then I need some keywords to mention in both my. I need some SEO keywords. You know, right? What is SEO keywords? So basically, it will give an advantage when someone is searching about that particular topics. So these keywords will be helpful to rank you better uh, in a Google search, right? So in that for keyword searching, I need some keywords related to that topic. So that is going to be my third task. So my first task is generating, social media content. My second task is generating a blog content, and my third task is generating SEO, search engine optimization related keywords. So these are my three tasks. For this, what I need, I for first thing, what I do, I need one prompt where I will mention generate, a social media content for the following topic. And topic is going to be, let's say, artificial intelligence or machine learning. So that prompt will go to LLM, and LLM will give the output. That output will go to the parser. So this is my first, my first task is going to end up, right? And my second task, what I need to generate a prompt, I need to generate a prompt saying that, so machine learning is my topic, and generate a blog content or generate a blog post on machine learning. Again, to generate that blog content, I need LLM. So what I, in second task, what I will do? I will implement block prompt, and then I will call LLM, and LLM output will go to parser, and parser will eliminate metadata and will give me a block content. In case 1, I am getting social media content. In case 2, I am getting block content. In case 3, what I need SEO friendly keywords. For that, again, I need one prompt, and that prompt will go to the LLM, and LLM will give the output to the parser, and my parser eliminate all unnecessary data and give me only a content, right? So if you observe carefully, you can identify that these three are not related on each other. This social media post is not related on blog post, and blog post is not related on my SEO keyword research, right? All three are independent tasks. So in this case, what I have to do, I have to use a runnable parallel, since all these three are independent tasks, right? I hope you got this. Let me clear this. Now, one more thing you have to observe. If you observe carefully, this social media prompt output has to go to my LLM, right? And my LLM output has to go to parser. It means there is a dependency between these three. There is a dependency between these three. You can clearly see that. So what I need, these three, since these three are dependent on each other, what I have to do, I have to make one runnable sequence. Runnable sequence. Let me say this is RS1. This is going to be my runnable sequence, correct? Because uh, uh, this task is dependent on this task, and this task is dependent on this task, correct? Then if you see my second task, and these three are dependent on each other, these three are dependent on each other, so these are actually should be executed in sequential chain, correct? So this is going to be my RS2, and these three tasks are depending each other. So this is going to be my third runnable sequence. My third runnable sequence, right? So this is going to be my runnable sequence 1. This is going to be my runnable sequence 2, and this is going to be my runnable sequence 3. So if you observe carefully, the structure we have seen here and the structure we are seeing here all are similar, right? So that's why what I am doing, I am taking three runnable sequences. I'm taking three runnable sequences. In the what I will do, I will take one runnable parallel. I will take one runnable parallel, and then I will execute everything. So I hope you got my point. In case still if you have a doubt, let me take you to the Visual Studio Code and then show you the code. Then you will get the clear idea. So let me clear it everything. Let us go to Visual Studio Code and start building this example using a runnable sequence as well as a runnable parallel, right? Yeah, guys. So yesterday we have seen this runnable sequence. Let me close everything. So we are in a folder called chains, correct? So inside chains, we have already seen runnable sequence. Now I am going to take a new Python file, which I will call a runnable underscore parallel dot ipynb. All right. So let me go to yesterday's file. Let's recap once what we have done. We have did whatever required imports, and then we have taken prompts, two prompts, because we need summary prompt and as well as we need poem prompt, and then we have taken one LLM, and then we have taken one parser. So if you observe what we are going to build, we are going to build a social. First we need one social media prompt, we need one LLM, and we need one parser, right? So total three prompts I need. All three are independent prompts, and in also will do my task. Yesterday we have discussed, right? Either you can take a single model, or let's say you feel that for blog content creation, OpenAI model is best, and for social media content generation, Anthropic or Claude or Gemini is best. So in that case, what you can do, you can take multiple models. Based on each task, you can assign one single model to one single task, or one single model to all the uh, tasks you can also assign. Right. So yesterday we have already discussed. Then everywhere we are using same parser, so we need to declare one parser, and same parser we need to use, because in the end we are just extracting a string. Correct. So let me. So if you see carefully, then yesterday's what we have done, and today what we are going to do. There is no change. In the end, what we need to do, in the end, we need to take one runnable parallel, and we have to pass all our runnable sequences uh, inside runnable parallel, so that they start executing at same time. Okay. So now let me do one thing. So from yesterday's program, I'm taking a same imports. Let me copy all these imports and then paste it over here. Let me take code node, paste. So we have taken chart OpenAI for LLM interaction. We have taken prompt. We are taking prompt template for generating prompts. We are taking a string output parser because we need to extract a string from the content from the LLM output. Then we imported runnable sequence, and then Google model I'm not going to use, so I will delete that Google import from my program. Now, if you see from .env, I am importing load env, so that it will load my OpenAI API in our program. Now, what extra we are going to import today is our runnable sequence. We are already imported. Since we are discussing about runnable parallel, along with runnable sequence, we need to import runnable parallel. And all these primitive runnables are available inside a package called a Langchain underscore core dot runnables package. Right. All right. So whatever 5 runnables we have discussed in the beginning of the session, all those 5 runnables are available inside Langchain underscore core dot runnables package. Right. Not only these 5, there are other runnables also there. If you have a time, go to the Langchain official document and you can explore all the runnables, since covering all runnables in our session is not possible. Right. So let me quickly import a runnable parallel now. Runnable parallel. Sorry. Runnable parallel. Right. So I have imported successfully. Now, what I need, first I need to construct 3 prompts. Correct. One prompt for social media, one prompt for blog prompt, and one prompt for generating keywords. Right. So let me, before generating prompts, we also, what we need, we also need one LLM, we also need one parser. So let me declare a parser as well as LLM. Right. So let me take LLM, and for LLM I'm going to import, I'm going to declare chart OpenAI, and I'm not passing any model. So by default it will take 3.5 turbo model. Correct. Then I'll declare a parser variable, and this parser variable is from string output parser class. All right. So my LLM is ready. My parser is ready. Now I need 3 prompts to be generated. Right. So my first prompt, I'm going to name it as a prompt underscore social. Since I'm generating a social media content, so I have given this variable name, which is meaningful name, right? Prompt underscore social. You can also give whatever name you want. Then let me take a prompt template. Inside prompt template, I have to take a template which is going to be write a social media post, right? Uh, if you want any character restrictions, that also you can mention. Let me do one thing, write a 150 characters social media post on the topic, right? And that topic will come in the variable. That is going to be my topic variable, right? So what I'm giving instruction, I need to you need to generate a social media post on the given topic in 150 characters. Why 150 characters? Because it is up to you. If you want to generate in 150 characters, 300 characters, or you can also eliminate this, so that sometimes it may give a lengthy social media post. Some social media um, generally may not accept a lengthy post, right? So that is the reason, since I want to post it in a multiple social media platforms, 150 characters I feel safer. That's why I have given 150 characters. It is up to you, right? Now, since this is the variable I have used here, what I need to do, I need to pass it inside my input variables. Let me take input variables is equals to inside array. I need to pass that particular variable topic. I have passed, right? So my prompt social is ready. Now, similarly, what I have to do, I have to declare one more prompt for what? For generating blog. For generating blog, right? So let me do quickly. Now I'll name it as a prompt underscore blog. Prompt underscore blog. And blog I will write 150 words. I feel it is enough for since we are just checking. I'll feel let us take limited words. So and this limitation up to you. If you don't want, you can also give without limitation. You can give the prompt. Write 100 words, a blog outline or any blog content on the topic. Blog outline or blog content, whatever it is on the topic, and topic is topic. So same input variable I have declared, and I have taken that similar topic. Now I need one more prompt for generating SEO keywords, right? Let me show you. So this prompt I need now. Let me go and create this prompt as well. So for this, what I'll do, simply I will change the name as a prompt underscore. Since I'm generating SEO friendly keywords, I'm going to give the name as a prompt underscore keywords. And here what I'll do, list 5 or 10 keywords, right? List 5 SEO friendly keywords. This prompt you can give anything, right? There is no issue on the topic, and topic is going to be topic. In this topic, we are going to pass it in a runtime. Correct. So now this is successfully done. Correct. Now three prompts we have declared. This prompt we have declared, blog prompt we have declared, keyword prompt we have declared, LLM we have declared, parser also we have declared. Same LLM we are going to use everywhere. So one LLM is enough. Same parser we are going to use everywhere. So one parser is going to be enough. Correct. Now, what I need to do in step 2, I am going to generate this runnable sequence first. Correct. So let me go and next step. What I'll do, these three runnable sequence I will generate, and then in third step, these three runnable sequence I am going to generate. Correct. So we need how many runnable sequence? We need 3 runnable sequence. This is going to be my first runnable sequence. This is going to be my second runnable sequence, and this is going to be my third runnable sequence. All right. So let me go there and let me take my first chain. Let me call it as a social underscore chain. Since I'm generating social media content, I'm taking as a social underscore chain is equals to use a runnable sequence, right? Runnable sequence. So inside runnable sequence, what I need to pass? I need to pass. Uh, social media prompt, one LLM, and then one parser. Correct. So let me pass. What is my prompt variable? My prompt variable is prompt underscore social. Right. Prompt underscore social, comma, and second one is LLM, comma, and third one I need to pass one parser. All right, so I have successfully defined my first runnable sequence chain. Now I'm going to declare my second chain and I'm going to call it as a blog underscore chain. Correct. Since we are generating blog content. Now let me add it blog underscore chain is equals to yesterday we have also seen you can also use runnable sequence, or you can also declare runnable sequence using a pipe operator, right? So let me use pipe operator this time, so that you will also not get confusion, you will get use of it as well, right? So in this what uh, I need again three things: blog prompt, one LLM, and then one parser. So let me take a blog prompt. My blog prompt is prompt underscore blog, prompt underscore blog. Use the pipe operator, and then LLM, use a pipe operator, and then we need in the end one parser to extract the content from this LLM output. See, uh, this and this represents same thing. Instead of using runnable sequence, we are using a shortcut called a pipe operator in between components, right? So both gives the both does same thing, correct? Now, so I have done my first chain, I have done my second chain. Now what I need to do my third chain. In this third chain, what I need: keyword prompt I need, LLM I need, and then parser I need. So let me declare that this time I will call it as a keywords underscore chain. Keywords underscore let me do it. Keywords underscore chain is equals to what I need: prompt keywords I need. Either I can take runnable sequence or I can use pipe operator, right? So let me take prompt keywords, pipe operator, LLM, pipe operator, and then parser. That's it. All my three chains are ready, right? Now, if you don't use runnable parallel, right? If you don't use runnable parallel, you have to invoke this. So let me do it without using a runnable parallel, and then I will also show you with using runnable parallel. Correct. So let me take social chain. How you are going to execute? Take this social underscore chain dot invoke. Invoke requires one dictionary object. Inside dictionary object, we need to provide a topic, a variable, right? Let me provide topic variable, and topic I'm going to give artificial intelligence or machine learning, any topic I can give, correct? Or anything you can change. If you want, you can also change it. Now I'm invoking social chain, so this will give me the output. That output, what I need to do, I need to store it as a result. Let me call it as a social underscore result. All right, guys. So clear, right? So this is the thing we have done yesterday also, right? Until we are not introduced runnable parallel, I just wanted to show you how much time it will take, and if you use runnable parallel, how much time it will take, right? Otherwise, there is no point of explaining runnable parallel, correct? Now let me import my blockchain. So I'm going to pass the same topic, and result I will call as a blog underscore result is equals to, instead of social chain, I need to call my blockchain. I need to call my blockchain. Now, third one is a keyword chain. So this what I'll do, a keyword underscore result, keyword underscore result, and I'm going to invoke this particular chain, right? So keywords underscore chain dot, I need to use invoke a method. All right. So now let me print all separately. Print social result, right? And then print blog result. Also, I need to print keyword underscore result. Keyword underscore result. All right. So let me execute it. So this way also we are we are achieving our final goal. Our final goal is what? Our final goal is we will give one topic. On that particular topic we need a social media content, we need blog content, and we need SEO friendly keywords. So our task is going to be finished. In this way also we can do our we can achieve our task. Let me execute this first. Let me take my virtual environment. Get started executing and see how much time it will take. So it will take much time because we need three LLM calls, right? So it will take some time. All right. So 11.8 seconds it has taken for completing this task without a runnable parallel, because all are running one by one, one by one. First chain, it will run first chain, let it finish, then it will go to second chain, it will finish, then it will come to third chain, then it will finish. That's why there is a delay of almost 12 seconds, right? So if you see the output over here, let me show you one second. So you can see that excited, see the endless possibility, and you also have some keywords in the end. You also have some social media content, everything. Since content is more, we are not able to see fully. You can see over dots over here, correct? So we are able to generate a social media content, a blog content, and as well as keyword result, and it took 12 seconds to us. Now what I will do, I will use runnable parallel and I will show you how much time it will take. Now let me copy everything. Some problem. I don't know what is the problem. So let me create a new file and I will call runnable underscore with underscore parallel dot ipynb. All right. So let me take a new code node and paste it as it is. Now, what I'm going to change, I'm not going to change anything till my runnable chain creation. Whatever the invoke part is there, right? That invoke part I'm going to change, right? What I'll change, let us see over here. I don't know guys what happened suddenly. So something happened. Give me a moment, guys. I don't know. Did I press something or no? I don't know. What did I press? I don't know, guys. Give me some time. I'll restart it. I don't know what is the problem. Let me save all, and then I'm going to restart. Let me restart it. So Langchain tutorial is my folder. Correct. All right. I'll let it load. Okay. So let me increase font size. I hope it is visible now. Yeah. Now what we have done, we have executed this and we have seen it took almost 12 seconds. Right. This is the one I think. Let me show you. This is fine. Kernel is crashed. That's why this error. Okay. Now we'll use the runnable parallel and then see the same invocation. Now what I will do, I'm going to comment all these lines because we are invoking each task separately. Now we will use runnable parallel and invoke all at one shot. Correct. So let me comment it. Now I'm going to implement a runnable parallel. Right. So for that, what I will do, I will declare a new variable called parallel underscore chain. Parallel underscore chain. Inside this parallel chain is derived from a runnable parallel class. So for sequence also we are doing same thing. What we have done, we are taking runnable sequence and then we are passing individual tasks. Correct. Here also same. We are taking a runnable parallel and then we need to pass individual tasks. So social chain is going to be my first task. Blockchain is going to be my second task. A keywords chain is going to be my third task. But only problem is a runnable parallel accepts in form of a dictionary. Input, it accepts input as a dictionary. So for that purpose, let me take input dictionary. Inside dictionary, what you need to store this task output somewhere, this task output some in one key, and as well as this task output in some key, right? So let me quickly add that all three things. Since it is a dictionary, I have to pass key value pair, right? So this is what I'm going to pass. What I'm passing? Social post, which will hold our social media post content, blog outline, uh, which will hold our blockchain's output, SEO tags, which will hold our keyword chain. So these keys up to you. You can social underscore post, blog underscore outline, SEO underscore tags. It is up to you. Whatever the key you want to give, you can give. Right. Now we have successfully constructed our runnable parallel. Now what I'm going to do is, instead of invoking social chain, blockchain, a keywords chain, directly I'm going to invoke a parallel chain, which will subsequently parallelly executes my social chain, my blockchain, and as well as my keywords chain. Right. So let me invoke that and then store the final result in a variable called result result. All right. Now, what is my final chain? My final chain is parallel chain. Just take that variable and then dot invoke. Invoke requires one dictionary. In that, I need to pass topic. Correct. Let me pass topic, and my topic is going to be a machine learning. My topic is going to be machine learning. Right. Now, in the end, let me print all my outputs. So same thing we are also doing here. In the end, we are printing all outputs. Using runnable parallel also, I'm going to print all outputs. So my first output will be having inside a parallel chain of a social post. Correct. My second output will be having parallel chain dot blog outline. That is what I have mentioned over here. And third one, it will be having inside parallel chain dot SEO tags. That what I have mentioned over here. I'm just printing all my outputs. All right. So now let me save it and then start execute. Let me take a same environment and let it start. So it is connecting to my kernel yet. My process has not started yet. Once it starts the process, you can see that I am over here, right? some problem. It is not going to connect, guys. Let me do one thing. Let me change my environment and then execute. Let me stop it. No, there is some error. Control A, Control C. I'll do one thing. I'll close this. I don't know what is the problem. It is not getting stopped. Let me go back to our previous program and I will take a new code node. And inside my new code node, I will add this new program along with my runnable parallel. All right. So now instead of executing this file, I don't know, this file is not executing. Let me close it. Now I'm going to execute this one. Correct. So it started execution. So you can see the time difference. Earlier it has taken 12 seconds. Now it is taking 9.3 seconds as well. It should not take 9.3 seconds also, because we have restarted Visual Studio Code and all. So that's why it is taking much time for connecting to kernel and all. So ultimately we got our output. If you see, this is my social media post. You can see over here. So it has generated my social media post, and then it has generated my blog outline. Correct. And then in the end, if you see, it might be giving my 5 SEO friendly keywords. Since content is more, I'm not able to see a full content over here. All right. So now we have successfully implemented our runnable parallel, and we have seen, you know, these three. Since these three are independent tasks, so there is no dependency that generating social media post should not be dependent on blockchain, right? Generating blockchain should not be dependent on social media post generation. So that's why we have used a runnable parallel, and then we have executed all these tasks parallelly instead of sequentially. If you execute sequentially, it will take a much time for the execution. So for independent tasks, you have to use a runnable parallel. So I hope I cleared a runnable parallel. With that, then we will go to our next runnable. Correct. So just a second, guys. All right. So now, so runnable parallel is successfully finished. Now, what is our next runnable? Next runnable, we are going to discuss which is a runnable pass-through. Runnable pass-through. We will discuss runnable branch, because runnable to discuss runnable branch, it required runnable pass-through and runnable lambda as well. So that's why we are not going to discuss runnable branch first. Instead, we are going to discuss runnable pass-through first. Then we will discuss about a runnable branch as well after this discussion. Correct. Now, what is runnable pass-through? Correct. If you see our definition here, pass-through means what? It will not do anything. It will not do anything. It will accept some input, and then it will give you as it is output. Whatever the input you send to runnable pass-through, say it will give you as a output. So basically it is passing, your input is passing as an output, right? So that is what pass through mean, right? So if it is not doing anything, right? If general question is, if it is not doing anything, why do we need to use this? Why do we need to use this? So there are some particular cases. So we need to use runnable pass through. One such case is yesterday's runnable sequence case. Yesterday's runnable sequence case. If you observe carefully what we have done in runnable sequence yesterday, we have successfully invoked this sequential chain, right? Once we invoked this sequential chain, we were expecting two outputs. One is, I want to see the poem over here. I want to see the poem over here. Second, I want to see the summary of the poem. I want to see summary of the poem. But for some reason, we are not able to see the poem. This sequence runnable sequence, what it does, it given only summary of the poem. So if you won't get output or whatever in the first LLM call, whatever poem is generated, we didn't get the output. So yesterday also I told you, when we are going to discuss about runnable pass through, we are going to solve this problem. So now we are going to solve this problem. Same chain we are going to execute using runnable pass through, and then we are going to get output as both poem and as well as summary, right? So this is our end goal for using runnable pass through. Now if you see the chain structure, if you see my chain structure, so my chain structure is going to be changed. So if you see here, what we need a 6 steps. We need 6 steps. Here also we need a same 6 steps. So this is going to be 3 steps, and this is also going to be 3 steps. Correct. But what I have done extra I have done a runnable pass through, so that this output parser will go to runnable pass through as an input and will get that same output. So, whatever the input runnable pass through is there, it will give the same output. Correct. And if you observe carefully, now I need one runnable sequence chain over here, one runnable sequence chain over here, and one more runnable sequence chain over here. Correct. This is one runnable sequence chain, and this is my another runnable sequence chain, and this is one runnable pass through. Correct. And then I have to execute these two runnable pass through and my chain 2 using a runnable parallel. Using runnable parallel. So let me say this is my runnable sequence 1. This is my runnable sequence 2, and this is my runnable pass through, which is 3, and these two are going to be executed parallelly. So here I need to use a runnable parallel of 4. Right. So don't get any confusion. So to simplify what we are doing, we are giving poem prompt to LLM. LLM will give the output. LLM will give the output, and parser will extract the output. And this output we need as well, right? In the case of sequential, you don't get this output because your chain will continue to execute, and in the end you will get the output. Correct. Here you will get the output. So in this process, you are missing your poem over here. But in this process, what we are doing, once poem is generated, we are executing 2 tasks parallelly. One task is going to be runnable pass through, which will take your poem as an input and gives poem as an output. And second runnable sequence I am running, what it will do, it will take your poem input and it will start generating summary and will give you a summary as an output. Right. So since these two are parallel chains, we need pass a dictionary. In the case of earlier case also we have seen we are passing a dictionary, so that your output will have a dictionary of your poem as well as your summary. Now, if you don't understand still, no need to be worried. Let's implement this in a program, then you will get the clear idea. Now, first, what I need to construct this chain. I need to construct this chain. And if you see this, this is a runnable sequence chain. Correct. So why it is runnable sequence chain? Because I have to construct prompt. That prompt is going to LLM, and that output is going to parser. Right. So this is dependent on this, and this is dependent on this. So that's why this is a runnable sequence chain. So let us build step 1 first, and then we'll move the further process of the chain. Right. All right. So for this, what I need again 3 things. One is prompt, one is LLM, and one more is parser. Correct. So let me go and declare these 3 variables first. Now, let me take a new file and let me call it as a runnable underscore pass dot ipyn. Okay. Now I'm going to do the same imports whatever we have done in runnable this import also I need to do, right? Uh, yes. So we have done it successfully. Now, since we are discussing about runnable pass-through, we need to import a runnable pass-through as well. Correct. So what I will do, I will import one more extra, which is called a runnable pass-through. All right. So I'm going to use both runnable sequence and runnable parallel. So you can see my chain structure over here. Runnable sequence also I need, runnable parallel also I need. So same structure over here, right? So these are runnable parallels because these are independent tasks. Now these two are independent tasks. I need to execute them independently using runnable parallel. Now, so first things first, what I need one LLM. Let me declare LLM first. So what I'll do, I'll add LLM and then I will take chart open AI. I'm not going to pass the model. Then I need one parser. Let me declare a parser which is derived from a string output parser plus. Correct. Now my LLM is ready. Now my parser is ready. I need prompt. Correct. So what I do, from prompt template, I can generate this one. So from yesterday's thing only, I have copy pasted, right? So poem underscore prompt is equals to prompt template dot form template. Either you can declare prompt this way, or you can declare prompt this way as well. There is no problem at all. So let me follow on this itself. So what my variable is going to be a poem underscore prompt. Correct. So let me comment it. Poem underscore prompt variable I have taken. I have taken prompt template. Inside template I am passing, and what I am going to tell, write a short poem in 4 lines about the topic. Correct. So let me replace it here. That number of lines you can define whether it is 4 lines or 6 lines, whatever numbers you can give. Now the topic is going to be my input variable, right? Now, so my all three components are ready. Correct. So now what I need to do, I need to connect these three components using a runnable sequence. So let me connect it, and I will call this chain as a poem underscore chain. Poem underscore chain. Now, poem underscore chain is a runnable sequence. Correct. Inside runnable sequence, what I need to pass, I need to pass poem prompt, I need to pass one LLM, I need to pass one parser. So let me pass all three components. My first component is going to be a poem underscore a prompt. Correct? Poem underscore prompt. And second component is LLM. So LLM I have declared. And then third component is parser. I have given parser as well. Now my poem chain is ready, successful. Correct. Now what I need, if you see here, I can also declare this chain. This is going to be my second chain. Correct. So let me declare this chain as well. For this chain, again we need three components. One is a summary prompt, one more is LLM, and one more is parser. So LLM and parser we already declared. Now I am going to declare a summary prompt. Correct. Now what I will do, let me take a new prompt. Let me take a new prompt and call this prompt as a summary underscore prompt. Summary underscore prompt. Now my template is going to be this one. Summarize the following poem in one sentence. So this is the poem. This poem will come from poem chain to this prompt template. Correct. So since I'm using text variable here, in my input variables also I have to pass a text variable. Correct. Now I need to use comma over here. Let me do the comma as well. Alright. Now prompt template is there, LLM is there, parser is there. So what we need? We need a summary chain. Let me construct summary chain. Summary underscore chain is going to be a sequence. Let me copy and paste it here. But this runnable sequence doesn't require a poem prompt, it requires summary prompt because this sequence is responsible for summarizing the poem which is generated in the poem chain. Alright, now my summary chain is ready and now my poem chain is ready. Now if you observe carefully, uh, give me a second guys. So this chain is ready, this chain is ready. Now I need to build this parallel chain. I need to build this parallel chain. And this parallel chain takes two inputs. One is runnable pass through and one more is a summary chain. Correct. So let me go over here and build a runnable parallel chain. So let me call it as a parallel underscore chain, which is from a runnable parallel class. Once you declare runnable parallel class, you need to pass a dictionary. Inside a dictionary, what you need? You need a poem. You need poem and poem where it will come? It will come from poem chain. It will come from poem chain. So for that, what I so let me do one thing. So from poem chain, poem will come, and then I need to pass runnable pass through over here. If you see here, poem will come, and that poem will go to runnable pass through, and as well as a summary prompt. So let me declare a runnable pass through class over here first. Let me declare a runnable pass through. This is my first parallel chain. So my first parallel chain is over and my second parallel chain is going to be this chain, summary chain. Correct. Now let me take my second chain, which is going to be give summary, and this summary will be a summary underscore chain. Summary underscore chain. Now if you observe carefully, this parallel chain we are not connecting with poem chain. This parallel chain we are not connecting with poem chain. Correct. So if you see here, so this parallel chain has to be connected to this sequence chain. Correct. Then only this output will go to both runnable pass through and as well as a summary prompt. So now what I will do, I will connect and I will make a final chain. Let me call it as a final underscore chain, which is going to be my poem chain, pipeline, and then parallel chain, parallel chain. Correct. So now what will happen when you invoke final chain? First, it is going to invoke your poem chain. In poem chain, what will happen? You will give one topic, it will generate one output. Correct. One poem, it will generate. That output will go to parallel chain. Now, parallel chain execution will start. In the parallel chain execution, what is there? Runnable pass through. Since runnable pass through responsible is whatever input comes, give the same output. So, in the poem, I am storing poem as well. In the summary, what I am doing, I am calling a summary chain. So, what it will do, it will take a poem as an input and will give the summary as an output. So, if you have confusion over here, you can also use a runnable sequence instead of, let me do one thing, final underscore chain is equals to, you can also use final chain like this, or you can also use a runnable sequence. Since these are sequence chains, runnable sequence, I have to pass poem chain. Correct. uh, Poem chain, and then I have to pass my summary chain. So like this also you can declare, but instead of that I have used a pipe shortcut, and then I have connected poem chain and as well as parallel chain. Right, both are correct. So let me comment and take this. Now what I need to do in the final step, I am going to invoke my final chain. Let me invoke my final chain. Final underscore chain dot invoke. Invoke requires a dictionary. Inside the dictionary, I need to pass the topic. Alright. So topic can be anything. For me, let me pass machine learning or artificial intelligence as my topic. Right. Machine learning. Machine learning. Now, this chain invocation completes. It will give the output. That output, I am going to store it in a variable called a result, and then I'm going to print my final result. I'm going to print my final result. Now, let me quickly show you in a runnable sequence. If you see this runnable sequence, we only got summary as an output. If you remember yesterday's session, we got only summary as an output, correct? Now, what we are going to achieve, we are going to achieve a poem as an output as well as summary as an output, right? So if you without saying poem, if you get the summary, what is the use, right? So that is what we are going to achieve. There is a spelling mistake. Let me correct it. Result and then a result. So I hope it makes sense. Now let me invoke my final chain. Let me save it and then execute. Let me select my environment. So it started executing. Ultimately, we should get result as a poem and then summary. Correct. Correct. So it is a bit difficult to see. Let me do one thing. Let me take a new code node. Since already this is stored in a result and result is a dictionary, what I will do, I will print both of them separately. Correct. Result of poem, result of a poem, and then print what is my second thing, summary. Result of poem and then result of summary. Let me print summary over here. All right. So let me execute it. If you want, you can give a line break slash n you can give, or you can give separate a print statement which will give the line break. All right. So since we have asked for 6 lines of poem, you can see my prompt. Write a short poem on 6 lines about the topic. So that's why it has generated a poem of 6 lines. Now, what in second step I am doing? I am going to summarize this poem, and then this is the summarization of that particular poem. So if you use only runnable sequence, you will miss getting the poem, but using a runnable pass through effectively, we are able to get a poem as well as the summary. So final underlying message is, using these things, you can make any complex chains or any complex workflows using a Langchain. So before going to implement any such kind of chains, I highly suggest you have your clear picture what you are going to do. Let's say if you construct like this, something like this, then you will get the clear picture what you have to do. Without doing this, without doing this work, if you completely jump into building these chains, then you will get confused, and you will end up with wrong output, or you will end up with something else. So what I highly suggest is, whatever chain or whatever workflow you are going to build, you think of some use case, and start drawing this workflow. Then you will get the clear picture where to use runnable sequence, where to use a runnable parallel, and where to use a runnable pass. Correct. Then you can implement these chains effectively. All right, guys. All right. With this runnable pass class 3 is over. Now we are going to enter into a runnable lambda. We are going to enter into runnable lambda. So what is runnable lambda? Runnable lambda is nothing but your custom function inside a Langchain framework. You can see that runnable lambda wraps a standard Python into a runner. Wraps a standard Python into a runner. Let's say till now we have seen that task specific runnables. Task specific runnables. Prompt we have seen. LLM we have seen. Right. Parser we have seen. These are all inbuilt task specific runnables. Inbuilt task specific runnables. What is mean by inbuilt task specific runnables? These are implemented by Langchain. These are implemented by Langchain. And what if you want to write your custom logic? You want to write your custom logic, and then you want to integrate your custom function inside a sequential chain or inside a parallel chain. For that purpose, what you need to use? You need to use a runnable lambda. In simple, what will happen? A runnable lambda class will make a standard function, right? A standard Python function to uh, into a runnable component in Langchain ecosystem. So this is the simple definition. Simple definition is a Python function is going to convert as a runnable component in Langchain using runnable lambda. So let us see the example, then you will understand this concept clearly. Correct. So let me go to my Visual Studio Code, and at this time again I'm going to take a new file. Let me take a new file, and I'll call it as a runnable underscore lambda dot ipyn. All right. So let me take a new code node quickly, and first we will see what we are going to achieve, and then we will jump into our notepad. First I'll see our workflow, then we will come back to our notepad. All right. So let me go to our this one chain. All right. So this we are going to achieve. This we are going to achieve. What we are going to achieve? We are giving some prompt to generate a joke, right? So my for this, what is my use case? I am generating a joke, and then I want to count how many words are there in that particular joke. Correct. So joke generation is one part, counting words are second part. Now joke generation, I need a joke prompt, I need LLM, and I need parser. So all three are inbuilt runnables in Langchain ecosystem. So I don't have any problem with this. But where I get the problem, for counting word, there is no inbuilt runnable inside Langchain ecosystem. Furthermore, I need to write my custom logic to find how many words are present in my joke. Correct. For that, in that case, what I need to define my custom function called word count, and then I have to wrap it inside runnable lambda so that my custom function will become a runnable function inside Langchain. So this is the simple runnable lambda. And what we are going to achieve, we are going to generate a joke, and then we are going to get output as joke, as well as how many words are present inside that joke. So this is what we are going to achieve now. So if you see clearly, first what I have given, joke prompt. Joke prompt will go to LLM, and LLM will give the output, and that output will go to parser. Parser will give me the output. So here I have a joke. Here I have a joke. Now, what is my next step? I need to get output joke as well as how many number of words present inside joke. Right. So if you continue the chain with my runnable lambda and word count function, what will happen? I will miss the joke, and in the end I will get only word count as an output. I won't get this joke as an output. So for that, what I have taken one runnable parallel. One runnable parallel. And this joke will go to runnable pass through. So what runnable pass through does, whatever joke input comes, it will give the output as it is the joke, and then same joke will go to my word count function, which is wrapped inside my runnable lambda. What this does, it will find how many words inside this joke, and then it will return a word count as an output. So because of this parallel chain, in the end, I'm going to get a joke over here, and then how many words are present inside my joke. So both I'm going to get. So this is what I'm going to achieve in this program. So I hope I'm able to clear my point. If that is clear, then let us start implementing our program. So now let's take a simple components. So this is my runnable sequence chain. This is my runnable sequence chain. So for this, again, I need one prompt, I need one element, and also I need one parser. Let's quickly create those required things. Correct. So what I'll do, I'll go to earlier example. Let me take up to prompt, or I can even take up to my chain. So all these things are again we are going to use. That's why I'm copying and pasting from my previous program. Correct. So what we are doing here, same thing. Chart OpenAI we are importing, prompt template we are importing, string output parser we are importing. We need a runnable sequence. Obviously, we need runnable sequence because this is runnable sequence. So these are my parallel chains. Correct. These are my parallel chains. So what we need to do, we need to import a runnable parallel. We need to import runnable parallel, and then I am using runnable pass through. So we need to import a runnable pass through, and then I am having my custom function wrapping inside runnable lambda. For that purpose, I need to import a runnable lambda as well. Correct. So these four runnables are required to achieve this specific chain. Correct. So if you see here, I have already runnable sequence, I have a runnable parallel, and also I have a runnable pass through. The missing component is a runnable lambda. Correct. Runnable lambda. Missing component is a runnable lambda. Now all my imports are done successfully. Now I have loaded my env file as well. I have created one LLM. Right. I have created one parser. Now I need to create a prompt. So instead of, since I'm generating a joke, let me name it as a joke underscore prompt. And prompt template is going to be what write a joke or generate a joke. Correct. About this particular topic. Write a joke about this particular topic. All right. So input variable again topic. I'm going to pass that topic when we are invoking that chain. Correct. Now, so instead of poem chain, what I will call it as a joke chain, since we are generating a joke. Now, so see the workflow. We need a joke prompt in a runnable sequence. We need a LLM, and then we need a parser. So I have taken runnable sequence. Instead of poem prompt, I need to pass a joke prompt, and then LLM, and then parser. So that will go and sit into my joke chain. So this is my first chain, right? So what is my first chain? This is my first chain. First chain is successfully finished. Now I am going to implement my second chain, which is a runnable parallel chain. So let me implement my parallel chain. Parallel underscore chain. This is going to be my variable, and then I'm taking a runnable parallel class over here. Now, what runnable parallel class is required? It required a dictionary. Correct. Dictionary. Inside a dictionary, if we follow this flow, joke is going to runnable pass through, and it will generate joke and give it back. Also, joke is going to my word count function, which I haven't implemented it. So I am going to implement word count function as well. Word count function as well. Correct. So first we'll build this thing, then I'm going to write my word count function as well. Correct. So let me do one thing. Instead of building a parallel chain, let me finish this word count function first. So we all know that how you declare a function in Python using a def keyword and then give a function name, which is going to be my function word count, right? So what this does, it will accept one string as an output and then it will give a length of words, right? It will take the joke as an input and give output as a number. So let me take one variable called a text. Let me take a variable called text. In case if you want, you can also specify which data type you are expecting, right? So these are general function stuff things. If you these are optional, so I'm not going to implement right now. If you want, you can implement those as well. Once that is done, what I need to do, I need to get word counts. I need to get word counts. So for that, what I need to split my text, right? I need to split my text and then I have to take the length of those words. So for that, what I will do, I will do it text dot split. So which is going to be a list of words and then I'm going to wrap inside my length function. So what it will do, it will give a word count and will store it in a variable called word underscore count. Correct. All right. Now what I need to do, I need to return this output. So let me return this using a return keyword and then word underscore count. That's it. So very simple function. It will take the joke as an input. It will start splitting. It will split and it will make the words and then it is going to count that words and store it in a word count. That word count I'm going to return it. All right. So my simple custom function is ready. Now what I need to do, I need to pass this function inside a runnable lambda. Then only it will become a runnable inside Langchain. If I don't wrap it inside runnable lambda, it is still a normal function. It is not a runnable function. Correct. It is a general Python function. Whenever I wrap it inside runnable lambda, then it will become a runnable. Correct. Now, so let me quickly generate a runnable parallel. First, inside runnable parallel, I need a couple of things. One is a joke and second one is word count. Correct. So let me, I have taken already parallel chain and then I have initialized runnable parallel and here I'm passing two keys. One is going to be a joke. Joke as it is I need, which is generated in joke chain. Correct. So I'm nothing to do here. That's why what I have to do, I have to pass a runnable pass through. Correct. Runnable pass through. This we have seen in an earlier example as well. What runnable pass through will take? Joke it will take as an input and joke it will give as an output. Now, once joke is done, what is my second task? Second task is going to be count my words, which is word underscore count. Here what I need to wrap my word count function inside a runnable lambda. Correct. Let me add it a runnable lambda over here and then pass my word count function. Pass my word count function. Now my parallel chain is ready and then my joke chain is ready. Correct. So this chain is ready. This chain is ready. Now what I have to do? I need to connect these two chains. Then only my workflow is completed successfully. Correct. If you observe carefully, this parallel chain dependent on my joke chain because joke is generating here. That joke input it is also expecting and this also expecting. Correct. So these two has to be connected with runnable sequence because these two are dependent tasks. Correct. So let me do one thing. What I will do now, I will construct my final underscore chain. Final underscore chain. So What is my first task? My first task to invoke job chain, and then my second task to invoke parallel chain using a runnable sequence. Correct. So let me take a runnable sequence. Runnable sequence. It requires both a job chain, comma, parallel chain. Parallel chain. Now what I have to do? Now I have a final chain. So there is one dependency when you are invoking this final chain. That dependency is going to be, let me show you. The dependency is topic. You need to pass the topic. So let me invoke my final chain, final underscore chain, final underscore chain. So final underscore chain dot invoke. Right. Invoke requires a dictionary object. With that dictionary object, you need to pass key as a topic. And whatever topic you want, you can pass it over here. And let me pass here. Alright guys. So this will give me the result, right? Now I am going to store in a variable called result result. Now, so it will generate a joke and it will pass to parallel chain, and parallel chain will give me couple of things. One is joke and as well as word underscore count. So let me print both. Print result of joke. Result of joke. Let me give a line break and then print this time result of it is word count. Correct. Let me paste it over here and then word count I have to paste it over here. Alright guys, so our chain is successfully completed and invocation is also doing. Now let us execute and see the output. Let me execute it. Select virtual environment. It got stuck. Give me a moment, guys. Just a moment. So anyway, it will give the error because I have selected a wrong environment. Then execute otherwise it will break. Okay, so it has generated successfully. Let me change my environment and do the same thing here. Lang tutorial is my virtual environment. So let me execute. All right. So this is my joke. It has generated. Why did the AI break up with its internet connection? Because it couldn't handle the band. So this is the joke, and I'm getting the joke as well as I'm getting a word count which has 16 words inside my joke. So if you execute again and again, a same thing is coming here. You observe again. I'm going to execute, and you got the different output. Alright. So why did the AI break up with its computer? Because it found someone who could pass press some joke it has generated, and the word count is 23 in that particular joke. So this is how you need to make any custom Python function into a runnable, runnable component inside Langchain. Alright. So now we have successfully discussed runnable sequence, runnable parallel, runnable pass through, and as well as runnable line. We all also seen practical examples. We have to use these runnable components. According to our agenda, one more runnable is left over. So now let me discuss that last runnable component, which is a runnable branch. All right. Now we all know what is branch, right? It is just a moment. All right. So when do we need to use runnable branch? Right. So till now we have seen several workflows where we never encountered a situation where we need to take some particular path based on some condition. Correct. So if you see, all are sequential. It is coming here, it is going here. Correct. If you see this chain, these are also sequential chain. There is no condition over or any chain, but a runnable branch will comes up whenever you need to decide something. Whenever you need to decide something. So let's say simple example. Uh, you pass a review to the L, right? You pass a review to the L, and you are constructing a prompt saying that classify this review as a positive or negative. Correct. So simple prompt you have passed. What LLM does? LLM will classify it as a positive sentence or negative sentence. Now, here runnable branch comes into the picture. Now, what will happen? Based on the response generated by the LLM, if it is positive, you need to execute some tasks. If it is negative, you need to execute some other set of tasks. So condition is applicable over here, right? So whenever you have such scenarios, whenever you have such conditional scenarios, you need to use a runnable branch. Using a runnable branch, you can decide which path to take, right? So let me take you to the, I know you didn't understand anything. Let me take you to the workflow first. I'll explain in the workflow first, and then I'll take you to the program. Then you will get a clear picture of when and why we need to use a runnable branch. Got it, guys? So let me take you to the workflow first. All right. All right, guys. So this is the workflow we are going to build now. I hope it is visible. Let me plus. So this is the workflow we are going to build now. What we are doing, we are taking a review and we are constructing a review prompt. That review prompt we are going to pass to LLM, and LLM will give some output. That output will go to the parser. Now, here is the condition. I want to do some set of tasks. If a review is positive, I want to do other set of tasks if a review is a negative. And then if LLM fails to understand whether it is a positive sentence or a positive response or a negative response, then I want to break my workflow there. So basically, my workflow execution will completely depend on this parser's output. On this parser's output. Correct. So if it is a positive response, you can see over here, earlier, I haven't given dotted lines in the case of parallel chains. In the case of parallel chains, what will happen? Both will execute. So this chain also will execute, and this chain also will execute. So both will execute in the case of a parallel. Correct. But in the case of branching, what will happen? Either it will execute this chain or it will execute this chain. If not parallel. If you want to execute any one chain based on particular condition, in that case you need to take a runnable branch. Correct. Now, runnable branch you are going to implement over here. Runnable branch you are going to implement over here. Now, runnable branch will decide based on the condition which sequential chain needs to be executed. So, I hope I cleared my point. What I wanted to convey. Now, in short, I'm passing one review to my LLM. My LLM will classify whether it is a positive review or a negative review. Sometimes it may fail, it may fail to understand the same. Correct. If review is mixing of both, or if you confuse the LLM, it is a possible case. Right? It may give you neutral, or it may give you not, it may confuse and it will give you some other output. In that case, what I'm going to do, if it is a positive response, I'm going to do one more LLM call, and I'm telling this is the response. So give a reply to this response. So that LLM will generate a response. If it is a negative response, I'm giving different prompts, and then I'm passing to LLM. LLM will generate review based on the response based on the negative response. If it is not positive, if it is not negative, I'm not doing any task. Alright. So whenever you want such if else conditions in your workflow, you need to use this runnable branch. So with this, I'm going to take you to Visual Studio Code, and then we'll implement this particular workflow. Alright. So let me quickly take a new chain, new file. Let me save it. Just 1 second, guys. All right. So let us implement our branch, another branch. Correct. So let me take a new file and call this file name as runnable underscore branch dot APY. All right. So let me take a code node, and then let me do all imports whatever we have done in the case of earlier program. Correct. All right. So chat OpenAI load.env prompt template string output parser. Yeah, string output parser. Uh, in this program, we need runnable parallel, a runnable branch, and then a runnable lambda. We also need a runnable sequence, but we no need to import runnable sequence when you are using a pipe operator. So that's why I'm not going to import. Now, if you observe the workflow, so normally if you directly pass one prompt to LLM and take string output parser, it may classify your review into a different things. Let's say LLM output can come as this review is positive, or LLM output can come it's positive, right? Or LLM simply can say positive review. All right. So if you see that you cannot predict output LLM when you are using string as an output. It may give anything. In the end, what LLM thinks, okay, I'm able to classify it as a positive or negative, but it won't care about the output. Output may come as a uh, uh, it is positive response, or it may simply say that it is positive, or it may tell something else which is meaningfully similar. But since you are going to write a condition over here, so that you that output you need to compare, right? So in this case, what you need to do, right? You need to force your LLM give only that particular literals, correct? Either give me positive The one way to do it in a prompt, you can clearly mention in a prompt you can clearly mention that. So this is my review. Correct. This is my review. Give me the sentiment analysis in just two words, positive or negative. Right. That is going to be a strict prompt with the instruction. Correct. So sometimes it may fail. Sometimes it may fail because LLM output we cannot predict in there. So for that, what we need to use a pydantic output parser. Right. We have discussed in I think session 3 or session 2 if I am not wrong. So using pydantic output parser, we need to force LLM output I need in that particular format. Correct. Then only I can implement my conditions correctly. If I don't do that, if I don't do that, here my conditions will fail and my workflow, I cannot expect my workflow's result as I wanted. Correct. So since I'm dealing with conditions, make sure LLM output, will come as a uniform every time. For that, we need to force uh, either JSON output parser you need to use or you need to use pydantic output parser. In this program, I'm going to take a pydantic output parser. So for that, I need to import my pydantic output parser. Also, I need to import, base model and field from the pydantic. And I also want to import a literal class from our typing library because in the literal, I'm going to mention I want only positive or negative sentence. So no need to worry. Let me import and then implement. Then you will get the clear idea. Correct. So let me do that imports whatever I mentioned right now. All right. So pydantic output parser. Why we need? We need to force my first LLM call. You have to generate output either in positive or negative, right? That pydantic, that's output parser I am going to declare that class I am going to declare in coming lines so that you don't need to worry. Now, from pydantic, I have base model I imported and field I have imported. Why we need field? Because inside field we need to pass a description, right? For that I have imported. Why here I have imported literal? Because either it need give me a literal of list either positive or negative. For that purpose, I have imported earlier. Now, with this, what I'm going to do, I'm going to load my env file first, load.env, and then let me take you to the flow. First, I need one review prompt, I need one LLM, and then I need one parser. Correct. But this parser is not string output parser. This parser is going to be a pydantic output parser. Correct. All right. So since there is no dependency for prompt and LLM, let me declare prompt and LLM first. Then this pydantic output parser requires a pydantic class that I will declare that class and then I will define my pydantic output parser. All right. So let me declare LLM first. Chart open A. Correct. I'm going to take a 3.5 default model, so I'm not going to give anything. Now my model is ready, and let me do one thing. So if you see the workflow, I need one review prompt here. Correct. I need one positive response prompt. I need one negative response prompt. So overall, three prompts I need. Correct. So what I will create my prompt one first, or prompt one, or you can call it as a review underscore prompt. So names are according to you. You can give whatever the name you want. Correct. All right. So let me quickly declare the prompt one. Uh, just a minute. So all right. So this is how we need to give the prompt, right? We need to give the prompt when you are instructing the LM to give in a particular output. You need to pass get format instructions. So for that, I need a Pydantic class. So let me do one thing. Let me quickly create my Pydantic class. So let me take class. And class name I'm going to take as a feedback class, which is derived from a base, a model. All these are we are already discussed in earlier sessions. I hope you remember. Inside, we need to give what keys you are expecting. Correct. I am expecting a sentiment. That's why I'm going to give a sentiment. And sentiment is a list of values, list of literals. Right. Let me do it from a literal of. I'm expecting only two words, either a positive or negative. All right. So I'm instructing the model whenever you are generating output, it should have a sentiment key. Inside sentiment key, it will have either positive or negative. Correct. So that description I'm going to assign using a field variable. Inside the field, I can pass my description. I can pass my description. So in the description, what I'm going to enter, give the sentiment of the feedback. Correct. Let me add it out. Give the sentiment of the feedback. All right, guys. So I have successfully generated my Pydantic class. Correct. Once I have generated my Pydantic class, I need to define my Pydantic output parser. Here also we have two output parsers. Let me show you here. So this is my parser and these are my parsers. Since here we are expecting only string output, so in two cases string output parser will be enough, but here we need a Pydantic output parser. Correct. So what I will do, I will take two parser variables. One is parser1, which is a string output parser. String output parser. Correct. Then a parser2, which is responsible for replicating this particular object. Correct. So for that, what I need to take, I need to take Pydantic output parser instead of a string output parser. Inside Pydantic output parser, we need to pass one variable called Pydantic underscore object, or you can simply pass a feedback class as well. If you want to specify that particular object, you can also pass something like this. All right. So Pydantic object, the feedback is going to be my Pydantic object. So I have mentioned over here. Now I'm going to construct my prompt one. I'm telling that in the template, classify the sentiment of the following feedback text into positive or negative, and I'm going to pass my feedback. Correct. Feedback is my actual review or feedback, whatever it is. User will provide this feedback, and then I'm also giving format instructions. What format I am expecting from this output. All right. So since feedback is my regular variable, I have passed inside my input variables, and this is the format instruction. So for that, what I have to do, I have to take a partial variable. Inside, I have defined the same key format instruction, and then I'm calling my parser2 dot get format instruction. So this particular feedback class format it will assign, right? So this is that simple it is. Now we have seen this already in session 2, and I think session 2 or session 3 as well. All right. So now my prompt 1 is generated, my parser 1 is generated, my parser 2 is also generated, my LLM is also generated. So let me take you over here. So prompt 1 is done, my LLM is done, my Pydantic parser is done. Correct. This LLM is also done, and this string output parser is also done. Now I need to generate a prompt 2 and as well as prompt 3 as well. So let me quickly add a prompt 2 and a prompt 3 as well. So let me take a new variable called a prompt 2, prompt 2, and my prompt 2 is going to be prompt template class. Inside prompt template class, let me pass my template. My template is going to be write an appropriate response to this positive feedback. Right. So prompt 2 I am considering as a this prompt. So I know at this point I know that this is a positive response. So according to that I am constructing my prompt 2. According to that I am constructing my prompt 2. Just a minute. So let me construct my prompt. So what I'm instructing, write a appropriate response to this positive feedback. And feedback is as usual. That user whatever passed the feedback, that feedback I am passing to my prompt to as well. Alright. Now I need to construct a prompt 3. It is going to be simple, but only thing is write an appropriate response to this negative feedback, because a prompt 3 is over here. At this point I know that user given a negative response to me. Correct. So for that what I have done, I have taken a negative response prompt. Write an appropriate response to this negative feedback, and feedback is going to be this particular feedback. Alright. So all things are generated successfully. Now let us divide these things. Let us divide these things. If you see, if you observe carefully, let me clear all these things. Just a minute. All right. So if you break this task, this is going to be one sequence chain. Correct. One sequence chain. After this output, my chain has to go to a runnable branch. Correct. Runnable branch. That we'll see how to do this runnable branch. But before we clearly know that this is going to be my first chain. So for that, what I will do, let me create my first chain first, and I'm going to call this as a classifier underscore chain. Why I'm calling it as a classifier underscore chain? Because it is classifying my review or feedback as a positive or a negative. So you can pass it in runnable sequence. Since I haven't imported runnable sequence, using a pipe operator, I can make it. Right. So let me pass my prompt 1. My prompt 1 will go to LLM, and LLM output I need to send it to my output parser, which is a pydantic output parser, not string output parser. In parser 1 we have a string output parser. Correct. In parser 1 we have string output parser, but here we are expecting pydantic output parser. That's why we are passing parser 2 in the chain. Correct. So I hope till this point everything is clear. Correct. Now after this, what is going to happen, I need one runnable branch. Correct. So then based on this output, based on this output, this will define. Based on this output, this will differ. Correct. If it is positive, it will take this chain. If it is negative, it is going to take this chain. If nothing is there, I'm not doing anything. Right. So I need one runnable branch over here, because at this point, I need to make a decision. At this point, I need to make the decision. All right. So now let me do one thing. Let me take my runnable branch. For that, what I will do, I will add it as a branch underscore chain, because I'm going to declare a runnable branch. Let me pass a runnable branch class. Since we are implementing runnable branch, obviously we need to take a runnable branch class. Now, runnable branch accept a couple of conditions. Couple of conditions. If you go to a runnable parallel, if you go to runnable parallel, where is the runnable parallel? So if you go to our runnable parallel, our runnable parallel is expecting additional, correct? But in the case of runnable branch, it is expecting tuples. So each tuple represents a single condition. So you can define if, elif, 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 and then else, right? So you can define n number of branches. But in this example, we need only three branches, right? So there is no rule that you should be having only two branches, three branches. You can have n number of branches, but you have to be careful while you are writing your branch conditions inside the tuples. Okay, so let me do one thing. What I will do? Uh, yeah. So let me add my first condition. My first condition is going to be I have to take the sentiment which is coming from the previous chain. Correct. So I will consider one lambda function over here. All right, one lambda function over here, and that lambda expects x as an input. Correct. Inside x, if you see my pydantic class, if you see my pydantic class, inside my class, a sentiment is the key. This sentiment will be holding either positive or negative. Either positive or negative. See, uh, you can directly take a lambda like this, or you can declare separate, separate function, and then you have to pass into another lambda. So which requires a lot of lines of code. For to simplification, I have taken a direct lambda function. Simple, nothing I am doing here. I am doing what I will do. I will get a pydantic object, and then I'm storing that pydantic object inside my x. Now my x is having a variable x is having pydantic object. My inside pydantic object, I have a key called sentiment, which will hold positive or negative. For that purpose, what I am doing, I am going to extract x dot x dot sentiment. Now I have to check whether it is a positive or a negative. Whether it is positive or negative. Let me add my a condition over here. Alright. So at this point, I know that it is going to be a positive. It is going to be a positive. Now what I need to do, if you carefully observe here, if it is positive, what I need to do, I need to execute this particular chain. I need to execute this particular chain, right? So what you can do, you can separately take a chain. You can separately take a chain and assign the chain over here, or you can directly, since it is a lambda function, you can continue your chain over here. But for simplification, what I will do, let me take a new chain and call it as a positive underscore chain. So in this, we know that it is a sequential chain. First, we need to generate positive response from, it will go to LLM, and it will go to string output pass. Correct. So let me declare that it is going to be my prompt to, right? Prompt to only I have given, right? Write an appropriate response to this positive feedback. So prompt to is going to be LLM, and then LLM's output is going to be parser 1, because we are expecting a string response instead. We are not expecting pydantic output parser. Similarly, I have one more chain which is a negative chain. Let me add it. Negative underscore chain is equals to, I need to take a prompt 3 over here, and then prompt 3 will go to LLM output will go to my parser 1. Alright. So if it is positive, I am telling that execute my positive chain. Alright guys. So I'm not doing anything, I'm just checking my sentiment. If it is positive, execute the positive chain. Correct. Now I will take one more tuple which is for a negative condition. Let me add it over here, and I will copy paste same content, but this time my sentiment will be negative. Correct. It might be negative. Either it will give positive. If it gives positive, it will invoke positive chain. If it comes negative, it has to invoke a negative chain. So let it pass a negative chain so that it will invoke the a negative chain. Now, if it is not positive, if it is not negative, for safer side, I am going to add one more condition, which is inside my runnable lambda. Um, what if it is not positive? You treat this like a default condition. If it is not positive, if it is not negative, then it will going to execute my runnable lambda, which will simply return could not find the sentiment. Could not find the sentiment. If, elif, else. That's what we are doing in the branch. If you have further more conditions, you can extend your conditions according to the requirement. Now, what I need now, I have a classifier chain in step 1, branch chain in step 2. Inside branch chain, my positive chain is done, my negative chain is done. If sentiment is not positive and not negative, and this is going to return me anyway, could not find the sentiment. Now, I need to match my classifier chain so that my parser to output will go to my branch chain. So let me build my final chain over here. Let me build final underscore chain is equals to. So what is the first step? First step is a classifier chain and then merge it with branch chain. Merge it with branch chain. So my final chain is a run. Correct. Now what I need to do? I need to invoke my final chain. Let me invoke that final chain. Final underscore chain is equals to final underscore chain. Oh, sorry. Final underscore chain need to invoke, right? Dot invoke. It expects the feedback, right? That is the feedback variable we have mentioned in our prompt 1, prompt 2, as well as prompt 3. So we need to pass the feedback. Let me pass a feedback here. Let me take a key feedback. My feedback is going to be, I'll write some general feedback. The product is very good. The product is very good. So we all know this is a positive feedback. I am expecting to be executed my positive chain. Correct. So let me store this output in the variable called result. Result variable I have declared. Once this is done, I'm going to print my result. I'm going to print my result. Correct. So I hope it is clear. Let me execute this first. Before that, I need to select my virtual environment and then start the execution. I'm expecting some positive response. Yeah. So this is simple. Just a minute. Field is deprecated. It is a simple warning. You can ignore that. You can see the output here. Thank you so much for your kind words. I am thrilled to hear that you had a positive experience. If you ever need anything else, please don't hesitate to reach out. So we have successfully generated a response to that particular positive feedback. Since this is a positive feedback, it is executed positive chain. If it is a negative feedback, it is going to execute a negative chain. Correct. So let us test that also. The product is horrible. The product is horrible or bad, whatever it is. You can give. Correct. Let me execute it. Now you can see the response. I am sorry to hear that you had a negative experience. We value your feedback and would like to make things right. Please reach out to us so you can address your concerns and improve. So a beautiful response it has been generated. All right. So that's it, guys. We have successfully used a runnable branch as well. Now, I highly recommend you to go to Langchain documentation import into your program, try to think of one use case and start implementing it. So with this, what will happen? You will not get any confusion while implementing. Where to implement runnable parallels, where to implement runnable branch, or where to implement runnable lambda. And all. So if you see over here, the moment I type runnable, you can see that there are several runnables are available. Runnable assign, binding, config, generator, map, pass through. So it is not possible to discuss all components exist inside runnables in a session. Correct. So we go through the document. So these are the mainly used runnables, but according to your requirement, you cannot expect that only these runnables you will use, right? You can get requirement of to use to another runnable, but these are majorly used runnables. That's why I have covered these runnables. So you want to explore other runnables, go to the Langchain document, search for Langchain runnables, you will get all runnables. They have documentation as well. You follow and try to implement it. So with this, let us go to our agenda and see what we have covered. All right, yes. So we have covered memory yesterday. We have covered multimodality. We have covered runnables or types of runnables. Sequence we have covered parallel, pass through, lambda, and then branch. So in depth, all these runnables we have covered with an example as well. All right. So with this, now only pending things are tools, tool calling, correct, and then building the first AI agent using Langchain framework. All right. So in the next week, our agenda is going to be, implement small tools and see how tool calling happens, and then we will also build a small, weather kind of agent first, and then we will jump into a capstone project where I will give you proper front end to chart with your agent, and then the agent, if time permits, we will also host it your agent in your EC2 environment. If time is not there, we will see locally, and then we will wrap this Langchain session. So with this, I'm going to end this session now. I hope you enjoyed this session. If you enjoyed, please hit like button, comment something. If you have any doubts, comment something. I'll try to address your doubts. And also, I'll make sure all these codes, whatever we have seen